Record. Okay.
Now you even recorded your email.
Yeah, exactly. All right, so this is gonna go really fast. We go to XSPEC. What am I doing? See. And you have your environment here, your plotting thing. I'm not even gonna load data right now. I'm just gonna show how to do it with a model, but the bottom line of this is anything you plot there. Anything, if I say I want to plot the EE mode, whatever is in the screen in that range is, I can write it into a file. So the way to do this, you go to the IPL, which I'm not sure how much we cover, but IPL is interactive plotting. So this is just kind of like a subsection where you can do things to your plot, change the labels, change things in an interactive manner. And here you use this command wdata, which means write data, and then you can just give it the name of the file, whatever name you want. And really the extension, the extension in general in Unix or Linux systems is irrelevant. It's not like in Linux that once you have an extension is tied to some programs. Here you can choose whatever you want. If you don't give it an extension, this program will put an extension by default. But you can just say, you know, this is a text file or, you know, whatever. And that's it. So what happened right now is what I am looking in the screen, those values that were used to produce this plot are now written in the file that I specify. So if I go and look at that file, you will see the first thing you see is these 3 lines. That is just information that is pertinent for one particular plotting software, but I'm not suggesting to use that. So you can forget about these lines. You can erase them if you want. They might actually cause problems in some software when trying to read the stuff. And then you have a bunch of numbers, a list of numbers, which is essentially for all the energies that you see in your spectrum, you have the information to plot that in. The first column is always going to be the x-axis information. So this is energies. Since you have energy in kV, that's what you're having here, energies in kV. The second column is the half width of your energy bin. So the first energy bin starts at this energy, and it clearly extends to this other energy. So in principle, you don't need this information, but for some reasons, it was important for the people that did this to keep what is the width of that bin, of that first bin that you have. And then the third number in this case is just going to be the model that you're plotting. In this case, it has these particular units, right? If you're plotting something else, if you're plotting the data, you will see other columns. You will see the data and maybe the error associated with each data point. If you're plotting, if you have several model components, you will see that as well. Maybe we can give it a try. But before that, I'll just show. So I'm not going to tell you what to use to plot. You should pick and choose whatever software you feel more appropriate. I think nowadays most people like to plot things with Python, with the matplotlib library. It's not very difficult. There are like a million of examples on internet how to do this. I think most of you probably already know how to do it. I'm old and I've used this thing called GnuPlot, which if anybody's interested, I found it very nice, but I just broke it in my computer and my system, so I cannot show you how it works. So there are many other plotting softwares. There is one called XMGrace, I think. I don't think I have it installed. This one has this one has a graphical interface that would allow you to do things. So as you can see, I'm not planning to show you how to plot things because that's not the meaning of this. You should all go and learn how to do it in your favorite software. If you don't know where to start, or you've never done it, or you don't know if your software, you don't even know which one to pick, you can ask us and we can give you a few pointers. But otherwise, Python is always a good resource nowadays. So going back here, I just wanted to show quickly another important thing. When evaluating a model, there's always has to be an energy grid. When you load a particular data, that energy grid is going to be defined by the response file that you're using for that data. But you can always define your own energy grid, and you can also even define your own response. So in this case, the RELSIL model, we have designed it in a way such as it picks an energy grid that is appropriate for the model, but that's not always the case. So some models, you do have to make sure that you have the right energy grid. And I'm mentioning this because it affects the model, but it also clearly is going to affect how you see the model. And this might change what you're writing these files if you want to go and plot it. So this is a thing we encountered yesterday with units, and I figure we never talk about it, but there is this command called energies. And this command in XSPEC, if you don't do anything, it doesn't do anything, but you have to tell what you can use it to tell what to specify the energy grid that you want for your model. So in this case, if you see here, we're going from 0.1 to 20, 30, 40 to roughly 50 kV. I could say, well, I want to make it bigger. I want to go from 0.01 to 1000 kV. Notice that I'm putting the points to specify that I'm dealing with energies. So the first one is the lower bound, the second one is the upper bound, and then the next number is the number of energy points that you want in that range, right? That will define what that will do is you're gonna control what's the resolution for the model. We're not talking about data. I'm not loading any data, as you can see. This is just all about how a particular model gets evaluated. So I can use maybe 1000 points. And finally, I can even specify, because I'm going in such a long range, as you can see, from 0.01 to 1000, we're talking about 5 orders of magnitude, so 5 decades in energy. So I'm going to say that I want this grid to be logarithmically spaced. If you don't say anything, the default is linear. But especially when in dealing with these big ranges, log is always a good choice. So that's it. That defines a new energy grid. And then if I plot again my model, you see that now the model gets evaluated in a much wider range. Okay. So what do you care about this? Well, sometimes you do need to see what the model is doing in a bigger energy range. The other reason for doing this is when you are dealing with convolution models, even though the data might be just defined in a small range, the model needs to be evaluated farther from that range because it's a convolution. So it needs to have information about what's happening farther energies. So in those cases, you need to do this. In any case, this is a good example to show that if I now go to IPL again and I say wdata file example 2, now I'm writing that in that second file. So if I look at the first lines of the first one that I did, you can see that one started 0.1 kV. That's what I had before. If I now look at the first lines of the second file that I created, it starts at a much lower energy, which is the energy I define with my new grid. Okay, so essentially, this is just to show clearly that anything that you have in the screen, if you dump it into the file, that's what you're going to get. And I think this is it. Very easy. The command is always wdata, and the second argument is always the name of the file where you want your data to go to. And then you go and you plot that however you want. Again, if you have questions, or need help on learning how to do pretty plots, plots that are good for papers, plots that are good for showing what you want to show, we can help you with that anytime. But this is just quickly what I wanted to show you, because I would like from now on in the next reports, I think the next one is probably the final one, but I would like you to try to make your own plots out of XSPEC. Every time you do a fit, you can produce your own plots. It's a little bit more work, but then I think that gives you the opportunity to understand what exactly you're looking at and how to make it better. So I stop here. I'm going to stop recording. I shared this